Hello everyone. Today let's solve the problem number 211. They have asked us to design add and search words data structure. So here what the question states here, we need to design a data structure that allows us to add words. You can clearly see here that allows us to add word and um, search words. Means we should be able to add words to the dictionary, and we should be able to search words where a word may contain dot that may match any character. So dot here might match any characters, as well as we have add words and search words. We have to add the words to the dictionary, and we have to search the words where word may contain dot matches any character. So this one we have to keep in mind, dot matches any character, right? So this is fine. So we have to design the data structure that allows add words to the dictionary and search words where a word may contain dots that may match any character. So um, we have to implement a class word dictionary with the following functions. One is add word here, another one is search. Add word, we are adding the word to the dictionary. Search of word, we this one return value is a boolean. We have to take care of this one as well, right? So initialization and the add word here, for these two, the return value is void or null in the case of JavaScript. For this one, these two return value is null. Only for this one, search, the return value is boolean. Either it can be true or false. So for the search of word, we have to return true if the word exists in the dictionary. We have to consider dot as well as a wildcard. Otherwise, if the word doesn't exist in the dictionary, then we have to return false, right? So that's what we have to do. So I'm telling this again, just keep this in mind. The return value of the add word and the return value of the initialization is void or null in the case of JavaScript. So let me clean this up. Only the return value of the search is boolean. It can be either true or false, right? So as usual, let's discuss the approach first, and then followed by edge cases one by one, and then finally write the code and discuss the complexities of the code that we have written. Initially, let's start with the approach. So let's discuss the approach step by step. First thing is, we are considering the data structure try as well as the backtracking. So this one we have to keep in mind. Again, I'm telling, we are just going with the try as well as backtracking. Try with backtracking. So I have just considered the same example that they have mentioned in the question, so that it will be easier to understand once we start discussing the approach. So let's see this one step by step. First, what we will do, we will start with a empty dictionary. Basically, why empty dictionary? Because that has to use the try, right? So we'll be making use of the try. So we start with the empty dictionary that internally uses a try to store the words. So we'll be making use of the empty dictionary that uses a try here. So to store the words. So we have to add the words to try. So what are the words we have? Here you can clearly see the add word. This one here you can clearly see. They have given for add word, we have to add the bad. We have to add bad, dad, and mad here. For the add word, we have used thrice here, add word. So word dictionary, this belongs to this one. Let's ignore this one. Add word, thrice we have got bad, dad, and mad. So is the value they have given. So in this case, let's do one thing. Let's add the words bad, dad, and mad to the try. So the try structure, initially we are going with the empty road, right? So the first step, let's ignore that one. Initialization, I hope the initialization is clear. We start an empty dictionary that uses the try to store the words. Now this will be root. So for adding the words, what it will be, basically we have three things. One is bad. So we are storing character by character when it comes to this one try. So this will be bad. This will be, so here, dad. And the final one, this one will be mad. So this one is mad. I hope this is clear. So add word of bad, dad, and mad. So that's what we have considered. We have added the words bad, dad, and mad to the try. So now the try structure looks like this, right? So let's consider one by one now. So now let's go step by step for each search query, right? So here, just give me a second in this case. So this one, word dictionary of empty array they have given. So this is initialization part, and this one first step will be basically, for the first one it will be null initialization part. So let's leave this one as it is. Second one, let's consider add word of this one, search add word of bad, dad, and mad. So we know that the return value of add word is null itself, right? So we know that one here, add word, return value of add word is null itself. So the second, third, and fourth will be null. Output will be null itself. So just give me a second here. Second, third, and fourth. Here it will be null itself. Let's go with the fifth one here. So just give me a second here. Fifth one was for search, right? Search of pad. We have to consider search of pad here. So let me come here. What we will do here, we have to we are going with the step by step. One we saw, this one was for initialization and it is null. Second one, initialization, so for the add word, sorry, for the add word method we have the return value null. And now add word of these words we had, right? Bad, dad, and mad. We have shown this one in this way. First word, first step, second step, third step, and fourth step. So fifth step, what we have here, we have search of pad here, right? Search of pad. So here you can clearly see the first letter P is not found in the try at all. Here we have B, we have D, and we have M here, right? So we don't have P here in this case. So the first letter P is not found in the try. So what we will do, we will return false. So this is for the search. The return value is Boolean. We have to return either as true or we have to return false, right? So this will be false because the letter P is not present here. This is fine. Let's move on with the sixth one. Let's check what is here. So this one is search of bad here. So search, we have to search for the bad here, right? So we have here B. In this case we are searching for the bad. In the sixth step we have B, we have A, we have D in the try. So B, A, D, we have this one in the try. So this is found in the try and we will mark this one as end. So this one we will mark this as end. Here this one we will mark this as end. Here this letter is marked as end. So D is end here and this one matches D, and all the characters are also present here, right? So this will be true. So the return value of the search is Boolean. So we are returning true here. We have to return true. Let's move on to the seventh one here. This one, search, seventh one, search of dot ad we have. So dot can be either, so it can be of any character, right? Dot can be of any character. Dot is at the first step. It can be either B, it can be either D, or it can be either M. Dot can be either B or D or M, the first characters of bad, dad, and this one mad. So dot can be B, D, or M. So we check each path recursively. So we can consider dot as B and then followed by AD. So it can be BAD, it can be DAD, and it can be MAD. So we can consider anything here. It matches right here. BAD, what? Yeah, BAD and DAD, and yeah, sorry, this one is BAD. It can be DAD or it can be MAD. So in it matches, dot followed by AD. This one matches. So this will be true in this case. So this one will be, seventh one will be true. The final one here, this one, let's see the final one here. search of B followed by double dots here. So B, we have the only thing here, the only word that is starting from B is mad. We have to consider this one. Just give me a second. We are considering this one in this case, bad. We are considering B. B followed by double dot, right? So this will be double dot. Let me consider this one as question mark here. It can be, question mark can be any character in this case, or dot can be of any character. So we can just consider here A and D. We have two characters. It can be A and it can be D. So this also matches. B double dot here. This one will be, we have the characters B, A and D. So this matches, and the output should be, the return value is boolean, right? It should be either true or false. In this case it matches, so here true. Why the last one we have got a true? Basically question mark can be of any character here. B followed by double dot. We should have two characters. Any character, two characters we have. The only thing is it has to start from B. B double dot we have got. So B followed by A and D. We have two characters. This matches. So the output will be true in this case. So the output here we got here is null 4 times initially. So that's what here the output is. Null, 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 null. So the last 4 we have here is false, true, true, true. False followed by 3 trues, right? So false, true, true, true. So this matches the output. So whatever we saw the approach, that matches the output that they have given in the question. So the approach works absolutely correct, right? So in this case, I hope the approach is completely clear. We are going with the try and backtracking, right? So I hope this is clear. Next, what we will do, we will discuss the edge cases one by one. So here, let's consider the first edge case. This is the first example, for the first example that we are considering, right? So it will be easier. So if we have the diagram, so we have the inserted word bad, this one dad, and add word of bad, dad, and mad as per the example. So we'll consider this one itself. First edge case is for searching for a word that does not exist. So I'll just give here searching for a word that doesn't exist. So I'll just give here that doesn't exist. So let me give here example. Let me consider here search of xyz accordingly with this example, search of xyz. So here we don't have xyz at all, right? Here we are going with the condition searching for a word that does not exist. So search, the return value is boolean, so we'll go with the false. This is for the first condition. Let's go with the second edge case, nothing but searching for a word that exists. So here searching for a word that exists. So when I say searching for the word that exists, so I'll go with the example search of dad here in this case. So let me go with the search of dad. This one we have dad here, search of dad. So the second one is dad itself here, this one, right? So the output here, search, the return value of the search is boolean. So the output will be true. Obviously we have the dad in the try. So let's go with the third case, third edge case, using dot at different position. So here I'll just give using dot at different positions. So suppose let me consider example here, search of double dot here, in this case double dot d. If I consider here this one double dot d, then for this one output will be true. We know this one. Why? We are considering this example. Double dot d means we should have two letters before d. We can consider either ba or da or ma in this one. So d is the last letter. Either we can consider ba, da or ma for the example. So this one will be true. And another example, if I consider here, search of let me consider d double dot here. So this one will be true as well, because here we have got D double dot. D starting letter has to be D followed by double dot. Dot means we can have we can consider any character. Here we have A and D. We should have two characters. Double dot means we should have two characters. It can be any character. A and D we have here. So this will be in this case also it will be true. This is for the condition using dot at different positions. Let's go with the final condition. Or the final edge case, it is for the condition searching with multiple wildcards. Nothing but dot again. Searching with multiple wildcards or dot wildcards. This is fine. This is for the final edge case. Nothing but dot here for the understanding purpose. So let's go with the example. Let me go here with search of 4 dots. Let me give here 4 dots. So this one will be let me go with the 3 dots. This anyway, we are searching with the multiple wildcards, right? Search of 4 dots, this will be false because we have only 3 characters, bad, dad and mad. Here we have 4 dots because the characters can be anything, but we don't have 4 characters at all, right? We have 3 characters in the try, so this will be false. Let me consider another condition here. Search of 3 dots here. 3 dots. So either it can be of any character. Either it can be B A D bad or D A D dad or M A D mad. So it can be anything, bad, dad or mad in this condition. So it can be any one you can consider. This one will be true. So these are the edge cases that we need to keep in mind. First one is for the searching for a word that doesn't exist. Second one is for searching for a word that exists, that we saw. Third one is using dot at different positions or using wildcards at different position. Fourth one is for searching with the multiple wildcards. So I hope the edge cases, all the edge cases are clear here. So next, let's write the code. I'll explain the code while writing the code itself, and finally discuss the let's discuss the complexities of the code that we have written. Now let's start writing the code. So first thing, let's come to the initialization part here. So as we had discussed, we are initializing an empty try root. First step, if you remember, in the approach we had considered, right? I mean, we had discussed, right? So I'll just give you this dot root. Let me consider, or let me initialize this one to the empty, this one empty object. So here we have initialized an empty try root for the initialization part. So next, let's go with the add word method. So here first what we will do, we will start from the root of the try. So we have to add the word character by character. Try will store character by character, right? So we will start from the root of the try. So I'll just give here node equals this dot root here. This is fine, I think. So next we have to iterate over each character in the word, all the characters, right? So we are iterating over the each character in the word. So how can we articulate this one in the form of code? I can just give here let char of word. This is fine. Hope this is clear. Next step, within the iteration, so if the character doesn't match, then we have to create a new node. So this is important. This we have discussed. So how can I articulate this one in the form of code? So I'll just give you a node of character, or it can be equal to empty. So this is fine. So final step is we have to mark the end of the word every time, right? So for all the words, we have to mark the end of the word as end, right? As true. So here node dot end, let me consider here 1, or you can consider the boolean value true as well. It doesn't matter. Either you can give 1 or you can give true. So we are just marking the end of the word in this case. So this is it for the add word method. Next, let's write the code for the search method. So first, we'll be making use of the DFS or helper function. So I'll just go with the helper function DFS here. Let's pass the parameters I as well as node. So just give me a second here. So yeah, this is fine. So the first step is, if the node doesn't exist, then we will return the false. So in the example, this one, especially pad we had searched for, right? P was not present in dad, mad, and bad. We saw that one while we discussed the approach. So the same thing, if the node doesn't exist, then we have to return false. So I can articulate in this way when it comes to code. If not of node, then we will return false. This is fine. So the next step is, if we reach the end of the word, then if we reach end of the word, then we have to check if it exists or not. So we will write the simple if condition here. In this case, if I equals length of the word here. So this one, let me give return double knot of node dot end. We are just checking if it exists or not by making use of double knot here, right? This is fine. I hope this is clear till here. Next step is, if the character is dot, then we will check all the possible paths, because here, if the character is dot, in this case, let's consider this one. It can be either B, here, it can be either D, or it can be either M followed by AD. All have the letters AD at the end. So it can be either B, D, or M, right? So for that one, we have to, if the character is dot, we have to check all the possible paths. So how can I write this one in the form of code? Let's return iterated value of the word here. This one, if it is equal to dot, then let's make use of the ternary operator. Let's go with the object dot keys. As we are dealing with the objects here, you can clearly see here, right? Just we are dealing with the objects here. So object dot keys of node and sum. We'll be making use of sum here. You have to know sum, every, map, filter, reduce. These methods you have to know at any cost. So sum, we will get the boolean value. So suppose we'll get the output in the form of boolean value, either true or false, right? So that is the reason we'll be making use of sum here. So sum of, let me consider key here, DFS, because the return value of the search is here boolean value, boolean, right? So that is the reason I'm going with sum here. Sum, every, map, reduce, and filter. These methods you have to know at any cost. If you don't know, please do Google, or you can just go through the JavaScript, this one, the JavaScript playlist that I have explained. You can just check that one. I have mentioned, I have explained everything with a example. So here, key, DFS of, so we are going with a recursive function here, I plus 1 and node of key here. So we are just checking if the character is dot, then we are just checking here all the possible paths here. So if it is not present, suppose if we don't have any letter before AD, then we have to continue matching normally or move to the next step, right? So here I can articulate the same thing in the form of code like this, DFS of I plus 1, same thing, node word of I. So first we will check this one. Suppose we have only here AD, we don't have B at all. Suppose yeah, suppose we don't have anything before this one. So then we will check this one and we will move to this one, right? So that's what we are doing here. D of I plus 1, node of iterated value of the word. So otherwise, we will just continue matching normally. So the final step here is, we have to start the DFS from root, right? So we have to start the DFS from root. So I'll just come out of the function entirely. So I have just come out of this function entirely. So here we are just starting the DFS from the root node or root. So I'll just consider here a return. So how can we write this one? DFS of 0, 0th index, and root. This dot root. This we are mentioning here. Nothing but we are starting DFS from root. I hope this is clear. Let me format the code once. This is it for the initialization, add word method, and search method. So I hope this is clear. Let me hit the run button. So here you can clearly see the sample test case is getting passed here in this case. Let me minimize this one and let me hit the submit button. So you can clearly see all the test cases are getting passed here. So the code works absolutely correct. In this case, whatever the code that we have written works absolutely correct. So let's discuss the complexities of the code that we have written. So the approach that we went with here is what? Try and backtracking, right? Try with backtracking, we can say. So what will be the time complexity here? The overall time complexity would be big O of n basically for the add word. So for the add word, it is big O of n. Why it is big O of n? So we are adding every character. We are adding uh, character by character when it comes to add word, right? So the time complexity would be big O of n, and for the search, it would be, so for the add word, it is big O of n, and for the search, sorry, just give me a second here. For the search, it would be big O of 26 to the power of d. So why it is 26 to the power of d for the search? Because um, for search with dot we are considering here, we have to consider all the possibilities for the search with dot. So here somewhere I have written in the search, so this one, right, return word of I, this one I have clearly explained. So what we were doing here, if character is I, we have to check all the possible paths, right? So in this case, this line number 18, so for this one, with the search, basically, this is for the search with dot. So overall time complexity would be big of 26 to the power of d, right? So I hope the time complexity is completely clear. The time complexity of the add word, and add word is big of n, and for the search it is big of 26 to the power of d. And what would be the space complexity here? The space complexity would be big O of n into L. So what is n and L here? N is nothing but the number of words, and L is nothing but the average length of the each word, or average length of the words that we have. So overall time complexity is big O of n for the add word, and big O of 26 to the power of d for this one, search. And the overall space complexity here is big O of n into L. I hope this is clear, right? I hope this is clear. I hope the solution is also completely clear, whatever we have written here. So for now, this is it. Thanks for watching, guys.